Alright, so the compiler might evaluate the expression. Okay, read if left hand side is evaluated first, execution if right hand side is evaluated first. Okay, or it might evaluate it in yet another somewhere. Explain the difference between prefix and postfix increment. So in prefix we increment first. Okay, so prefix is update first, then use, and postfix is use first, then okay. What happens if the while loop on page 148 that prints elements from a vector uses a prefix increment operator? What happens if the while loop on page 148 that prints vector uses the prefix 148 used the prefix? Oh, okay. So here it uses the prefix operator. Okay, then we would miss, right? We would have missed one value. Right. So in that case we would miss the starting value. Okay. Since it would increment first, so we would miss the value at index 0. Let me try. Let's confirm it. Okay. This is section 4.5. This is 4.18. CPP. Okay, so I can create a vector of int, say I and then I can initialize it with a list. Let's say 1, 2, 3, 4. Okay, that is simple. Then we go auto equals I vec dot begin I vec dot end. We'll go in the loop. We'll say begin is not equals to end, right? That is how it is done. Right. Begin is not while, right? While, so I can just use the while loop. While begin is not end, I want to First begin. Right. Hmm. So the question is, what would happen if the volume use the prefix increment operator? Okay. See if it throws any errors. Hmm. Okay. So we missed the first element, and then we even traversed. Okay. First increment, so we would miss the value at index 0 and would even go past the end iterator. Go past, no, and would even reach the end iterator and print its value. Okay, given that PDR points to an int, that vector a given PDR points to an int, that vector is a given that PDR points to an int, that vector is a vector of int, and that IVAL is an int. Points to an int. PDR points to an int. That IVAL is a vector, and that IVAL is int. Explain the behavior each of the expression, which if analysis is likely to be incorrect, or why, and then we have how each might be corrected. Okay, so pointer is not 0 and value of pointer is valid. Well, okay, is less than equals to, this is wrong. Okay, given that Peter is a pointer to int, vec is a vector of int, and that IVAL. Okay, pointer is not 0, and we are incrementing the pointer and then dereferencing it. Which if any are likely to be incorrect, how might each be corrected? Figure. Vec of plus less than equals to, oh, okay, you want to check, right? So we'll check if the current, okay, so I'll say this is wrong, since we can't assure which value will be overloaded first, since we are using the same variable after incrementing in the expression, right? So what you can do is okay, how might each be corrected? Since we can't show each other, since we are using the same variable after incrementing it in the expression, which is undecided. What was the name for the behavior? Undecided. Yeah, same. You can't use the same value. It was not undefined. It was not undefined behavior. It was the hmm. No guarantee of evaluation is like guaranteed operation of when the cases where it does matter. So one subexpression changes the value of an operand that is used in another subexpression because the increment and decrement operator change their operands. Okay. Okay, this is correct because it evaluates the left hand side first, right? Then only if it evaluates the right hand side. I plus plus I val. Okay, this is wrong. And the both values are not same. I val and I val. Okay, hold on. Right, so how can I fix that? Which is undetermined. The way you can fix it is by incrementing the value after the comparison. So I can go with vec ival vec ival plus 1 and then plus ival. Okay, this is correct because it will evaluate the left hand side If it is not 0, only then will it try to dereference it. Okay. ival plus plus and ival. Okay. I don't know. I'm not sure about this, so let's ask my guy. Given ival is an int, is the given expression valid in C++? The expression is valid at playtime will post increment, it increments but yields the original value before, and result it converts to bool by contextually performing. Okay, both operand ival and ival which are converted to bool evaluate current left to right. Okay, yeah, that's yeah. So I thought so it was correct, but this expression is not correct. Okay, the member access operator. The dot and arrow operators provide for member access. The dot operator fetches a member from an object of class type. Arrow defined so that PTR mem is a synonym for dereference and then access. Okay, string S1. You create a pointer string and S1. We have auto n equals size set 1 n equals dash size, size because dereference has a lower preference than dot. Alright, we must parenthesize because dereference has a lower preference than dot. We must parenthesize the dereference expression. Yes, correct. If you omit the parenthesis, this code means quite different. B, the pointer has no member access. Right. Okay. So this expression attempts to fetch the size member of the object P. However, P is a pointer which is no member. This code will not compile. Okay. So we have the arrow operator requires a pointer operand. The arrow operator requires a pointer operand and yields an L value. The dot operator yields an L value if the object from which the member is fetched is an L value, otherwise result is an R value. Okay. Assuming iter is a vector string iterator, indicate which of the following expressions are legal. Following expressions are legal. Explain the behavior of the legal expression and why those that aren't legal are in error. Okay, this is correct. This is correct. Iterator. Iterator. If I dereference the, okay, this is incorrect. Then this iterator is like a pointer, right? Okay, postfix operators. Postfix operators have higher preference than the dereference operator. This is correct. This is also correct. Now the dereference. Okay, if I am iterator, right? If I dereference, okay, so iterator has no member function empty. Dereference has it, right? This is also correct. Equivalent to this. Okay. Plus plus operator. Yeah, this is a little. Okay, this is also correct. I don't know about this one. I would have to try. Okay, so we'll check exercise section 4.6. 4.20. Okay, so we create a string. Let's hello. Okay. Okay, vector of strings. Alright. So I have a vector of strings. Okay. Vector of string. Related to that. This is vec. Hello. Hi. What's up? Data is swig dot begin. Okay, so I'll say, see, this is valid. This is begin. T. Pretty sure this is valid. Yeah. So then we have, yeah, I want to see, so it will dereference, it is right associative, this is there, this is invalid code, you know. Yeah, iterator, the operator has no match. Yeah. Okay. And this is also wrong because if you go, it will say that dot operator has higher preference than dereference. So it will say, okay, so let me go. This is also valid here. I'm pretty sure. Yeah. Okay. So yeah. So it will say that the iterator has no member function empty. There we go. Okay. So we have the conditional operator. The conditional operator, question mark and colon. Let us embed simple if-else logic inside an expression. Where condition is an expression that is used as a condition, and expression 1 and expression 2 are the expressions of the same type. Oh, same type. Or types that were converted to a common type. This operator executes by evaluating condition. If the condition is true, expression 1 is evaluated, otherwise expression 2 is evaluated. As an example, we can use a conditional operator to determine whether a grade is pass or fail. Okay. So the condition checks whether grade is less than 60. If so, the result of the expression is fail, otherwise the result is pass. Okay. Like the logical and logical OR operator, the conditional operator guarantees that only one of the expression. Okay. Like logical and OR operator, the conditional operator guarantees that only one expression is evaluated. Okay. So only one will be evaluated, both will not be evaluated. So we have the result of the condition operator. The result of the condition operator is an L value if both expressions are L value or if they convert to a common L value type. Otherwise, result in R value. Nesting conditional operation. We can nest one conditional operator inside another. That is, a conditional operator can be used as a condition or as one or both of the expressions of another conditional expression. Okay. So as an example, we'll use a pair of nested conditionals to perform a three-way test to indicate whether a grade is high or ordinary. Okay. So if grade is greater than 90, if it is not, then we'll check if it is less than 60. Okay. The first condition checks whether the grade is above 90. If so, the expression after the question mark is evaluated, which yields high pass. If the condition fails, if the condition fails, the colon branch is executed, which itself is another conditional expression. This conditional asks whether the grade is less than 60. If so, then question mark is evaluated and the yields fail. If not, this branch is evaluated and pass. Okay. The conditional operator is right associative, meaning as usual that operator groups right to left. Associativity counts for the fact that right hand conditional, the one that compares grade to 60, forms branch. Okay. Nested conditionals quickly come unreadable. It's good idea to nest no more than 2 or 3. Right. Then we have using a conditional operator in an output expression. The conditional operator has fairly low precedence. Whether we embed a conditional expression in a when we embed a conditional expression in a larger expression, we usually must parenthesize the conditional sub-expression. For example, we often use the conditional operator. To print one or another value, depending on the result of a condition. Okay. So this prints pass or fail. Okay. 60. For example, we often use a conditional operator to print one or another value depending on the result of a condition. Alright, so an incompletely parenthesized conditional operator in an output can have CL prints 1 or 0. The second expression uses the comparison between grade and 60 as the operand to the operator. Okay, the value 1 or 0 printed depending on whether grade is less than that's false. Right. Well, return Cout, which is tested as the condition for the conditional operator. That is the second expression is equivalent to question mark cout fail pass. Test cout and then yield one of the two results depending on the last expression is an error because it is equivalent to cout. Okay, yeah, cout less than. It prints grade. Okay, less than has lower precedence than shift. So print grade first. Okay. Compare cout to 60. These are not comparable values. Cout will result true. Cout depending on whether cout is true or false. Yield one of the two values depending on whether cout is true or false. Okay. Then we have some exercises. Then I have bitwise operators. Okay. So we write a program to use a conditional operator to find the elements in a vector that have odd values and double the value of each element. Okay, this one is easy to do. Section 4.7. Okay, now this is exercise 4.21. CPP. One, two, three, 4. Okay. Write a program. Find the elements in a vector that have odd values and double the value of each such element. Extend the program that assigned high pass fail grade to allow assign low pass grades below 1675. Write two versions. One version that uses only conditional operators, the other should use one or more if statements. Okay, which version do you think is easier to understand and why? Hold up. Okay, write a program to use conditional operator to find the element in a vector that have odd value and double the value. Okay, that should be easy. So I was actually doing 4 to 1, right? Okay. So next, say I back. So we can go with x equals spot 2 x times 2. Okay. Alright, so let's try and, um, and grade equals, okay, if I'd say 95, so it should go to high pass. Right, right. Okay, so we'll go with, I want to print final grade. Right, okay, so this is 4.22, section 4.22. Okay, high pass, right. Then we go with 80, which should be simple pass, right. Then we go with, let's say 75. This should be just pass. Ah, low pass. Right, yeah, okay. This is low pass. And then if you go with 50, this should be fail. Yeah, okay, great. Then I have to make another version. If grade greater than 90, right? Then we go, final grade equals high pass, else we can evaluate if grade greater than, sorry, if grade is less than equals to if grade is less than equals to 75 and grade is greater than equals to 60, then okay, if it is less than, so final grade is low pass, else okay, else we just go final grade equals pass, and then I feel like an else if grade is less than 60, you can go with final grade equals fail. Okay, let's forget about this and let's do this at the end. Compile this. Yeah, okay. Okay, fail. So 50, yeah, right, fail. If I go 100, that is high pass. Then we can test for 80, that is pass. And then let's say 60, it should be low pass. Sorry. So I've got this, then I have the following expression fails to compile due to operator precedence. Okay, using the table, explain why it fails and how would you fix it. Okay, so arithmetic operator. Okay, equality operator. Right. Okay, so page 166. Let's go to page 166. Alright, so we have relational operators. Right, relational operators have, okay, binary at, and this is assignment. Okay, so I have, okay, so this condition would always be true because first we add, right? First these brackets will be resolved. So this will be size minus 1, that is 4 minus 1, 3. So we'll go s plus s of 3 equals s compile to do operator precedence, right? This has more precedence than this, right? Although this would result in a bool. Okay, so it is okay. Left to right, so I can fix it if I go like this. So if the last is equals to s, then we add nothing to the word else fixed. Okay. Our program that distinguish between high pass, pass, fail depended on the fact that conditional operator is right associative. Describe how that operator would be evaluated if the operator were left associative. Oh my god. It associates from the right. So if it were left associative, that means it associates from the right. Means it associates, okay, this colon will associate with the first question mark, right? And this is its condition. Then this colon associates with, okay, right associative. Okay, so this colon associates with this, right to left. This colon associates with this, and this colon associates with this. Okay, so if I go, this colon associates with this, so it would have gotten this entire block is a condition. It's a condition to this. Then it associates, it would have associated, right? Well, I don't really want to do that. Okay. Okay, that's good enough.